Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on classification of DC motor, that means types of DC motor. So what are the types? So first, depending upon the field winding and armature winding connection, there are two types of DC motors. First one is separately excited DC motor and self-excited. There is no connection between field winding and armature winding. Or method of excitation, field winding excitation, we are classified as the DC motor into two parts, two types: separately excited and self-excited DC motor. In the self-excited, again three types of DC motor. So first one is shunt wound DC motor and series wound DC motor and compound wound DC motor. In the shunt wound DC motor, armature winding and field winding are connected in parallel. And in case of series wound DC motor, armature winding and field winding are connected in series. And in the compound wound DC motor, there are two types of two field windings and one armature winding. So one armature winding. So one field winding is connected in series with the armature winding, and other field winding is connected in parallel with the armature winding. Now here three types of self-excited DC motors: shunt, series, and compound DC motor. Compound wound DC motor. Again, compound wound DC motors are classified into two types. So long shunt and short shunt DC motor. So here long shunt and short shunt DC motor we can use as a cumulative type and differential type DC motor. So cumulative type means when here one field winding is connected in series with the armature winding and other field winding is connected in parallel with the R winding. One is connected in series and other one is connected. If two field windings are added, that means there is an addition. That means cumulative type. If two field windings are subtraction, so cancel of each other, so such type of DC motors are differential type DC motor. DC motor, long shunt and short term. So same we can use as this cumulative type and long shunt and short shunt DC shunt motors as a cumulative type and differential type. Now let us explain separately excited DC motor. Separately excited DC motor means armature winding and field winding are connected in there is no connection. If there is a connection, that means a self-excited DC motor. So now here this is A armature winding and F are field winding. So now is there any connection? There is no connection between between these two armature winding and field winding. Now this, because of that reason, it is a separately excited. So field winding is excited with separate supply, that means battery, and this field winding resistance is SRF, and it is connected to the supply, means current flowing in this, that current is IF. And so now here we are giving the field wind. This is the stationary magnet, and here we are giving supply voltage. So we are giving electrical energy to this DC motor, and so that that voltage, the supply voltage is V, and this IL is the line current, and here this supply and this armature are connected in series. IA and IL are connected in series, means that IAL equals to IA. So this armature current is IA and this armature resistance is RA, and there is a back EMF induced in the armature. That back EMF is EB. So these are the terms. So now when you give a supply to the DC motor, and mechanical energy will be generated, that means motor principle. So now here, to generate that mechanical energy, current carrying conductor placed in a stationary magnetic field, mechanical energy will be developed. So current carrying conductor placed in a stationary magnetic field, it experiences a mechanical force. That stationary magnetic field, with the help of this battery and current carrying conductor. So current carrying conductor is acts as a magnet. So that is obtained from the another source. There is no connection between these two. Now let us see the terminology. EB is the back EMF and V is the terminal voltage, this one, and Vs is a battery and this one battery voltage, and next IL is a line current, so this one IL. Next IA is the armature current, this one, and RA is the armature resistance, this one, and IF is the field current, this one, and RF is the field resistance, this one. So these are the terminology. So now let us find the armature current, back EMF, next formulas, and RSH and ISH formulas. Now, so first IA equals to IL. So why IA equals to IL? So these two currents are same. Why? Because these two are connected in series. In case of series connection, same current flows to the each element. So IA equals to IL. So next case, this IF equals to this Vs divided by this RF. So this voltage divided by this resistance equals to this current. So now is it okay? Next case. So this IL equals to this RB, RE. So now not RL. This IL equals to this is the RA. This voltage divided by this resistance is known as a RL. So now IL equals to this V by RA. And next, so if you apply KVL in this loop, so back EMF is equal to V plus V minus IARA. In case of DC generator, so DC generator, separately excited DC generator, so EB equals to V minus IARA. So in case of DC generator, there is a plus. In case of DC motor, there is a minus. Now here mechanical power developed by armature. Mechanical power developed by armature means, so that means EB into IA. So that is PM equals to EB into IA. These are the formulas which are used in the problematic. So now here most important problems: armature current and field current and back EMF and line current formulas are most important. After that, after getting IA and EB, you can calculate the power developed by armature. Next case, self-excited. In the self-excited shunt wound DC motor. The shunt wound DC motor means, so first armature winding, there is a connection between armature and field winding. So there is a connection. That connection is parallel. And if you give the supply to this, so supply voltage is V, we are giving electrical energy to the DC motor, and so current carrying conductor placed in a stationary magnetic field. This stationary magnetic field, this is electromagnet, it is excited with the self-excited, and mechanical force developed in the armature towards a particular direction. Now here this is RA, armature resistance, this is the RF or RSH, it is a shunt RSH. Now here let us see the terminology. EB is the back EMF. Back EMF will be developed in the armature conductor, and V is the terminal voltage, and terminal voltage this one, and IL is the line voltage, and next IA is the armature current, this one. IA is the armature current flowing through this armature, and RA is the armature resistance, and RSH is the shunt current, this one. This is the shunt current. We can call it as RSH, ISH or IF. So it is a field winding. Field is connected in parallel. So it is called as shunt current or shunt resistance. And this is RF. We can call it as RF. Now let us see the formulas. So formulas related to this one. So now what are the formulas here? So IA current, ISH current, and EB, back EMF. So what are the, so IA equals to, if you apply KCL, what is KCL? KCL statement. So sum of algebraic sum of currents at a node equals to 0, or sum of entering currents at a node equals to sum of leaving currents. Here what are the entering currents here? So entering current is IL and leaving currents are IA and S. Now IA equals sum of IL equals to this, IL equals to IA plus IF. IA plus IF. Sum of entering currents equals to sum of leaving currents. Entering currents equals to leaving currents. So now here IA equals, here we need IA equals IL minus IF. IF means this IA equals to IL minus ISH. So now here IL equals to IA minus ISH. Now here IA equals to IL minus ISH. Now next one, ISH equals to V by RSH. This same voltage developed across each element. Same voltage developed across each element. So this voltage, this voltage, this voltage, and this voltage is same. Now here IL equals to V by RL. So this is the RA. So this is RA. This voltage divided by this one. So don't use this one. And next, EB equals to, if you apply KCL, so here EB equals to V minus IARA. EB equals to V minus IARA. And mechanical power developed by the armature, that means that equals to PM equals to IA into EB. So this EB into IA. Mechanical power developed by the armature. So now here IL equals to, don't use this formula, IL equals to IA minus ISH. So now here if you apply, this is entering currents IA equals to IL minus ISH. This is IL minus ISH. So now next case, series wound DC motor. Series wound DC motor, field winding and armature winding are connected in series. Now here supply voltage and field winding and armature winding all are connected in series. So now these are connected in series means supply current, a line current and series current and armature current all are same. IL is the line current, I series is the field current, series field current, and IA. So this current IL equals to I series equals to IA. This is most important. Now, so the terms related to this, EB is the back EMF and this one, and V is the terminal voltage, this one, and IL is the line current, and IA is the armature current, and RA is the armature resistance, this one, and I series is the series current, or we can call it as IF, and R series, this one R series or RF. If it is shunt, that is ISH. If it is series, and that is I series. So both are field windings. So now here these are the terms related to series field winding. And next, now here. So what are the formulas? IA formula, I series formula, and EB formula. First, IA equals to IL equals to I series. So same current flows to the each element in case of series circuit. IA and I series and IL are same. Now here EB equals to, so this EB equals to, this is RA and this is R series. Now here if this is the, this direction. Now here V equals to, algebraic sum of total voltages in a loop equals to 0. So this V minus IA RA minus I series R series and minus EB equals to 0. So this algebraic sum of total voltages in a loop equals to 0. But this IA and I series are same. So you can substitute in place of I series, that is IA. So that equals to this one. And next here IA is a common term. So now here this IA equals to this I series. Now here the final equation EB equals to B minus IA RA plus R series. Now mechanical power developed by this armature, that equals to PM equals to IA into EB. Now next, long shunt DC generator. So that means in the compound DC shunt generator there are two types of generator, long shunt DC motor and short shunt DC motor. So first long shunt DC generator, DC motor, one is one field winding, So there are two types of field windings, one field winding, other field winding. So one field winding is connected in series with the armature and other field winding is connected in series with the armature. And supply. This is a supply. Now what are the terms related to this long shunt engine? EB is a back EMF and V is the terminal voltage and IL is a line current and IA is the armature current and RA is the armature resistance. Next, I series is the series current and R series resistance and ISH and shunt current, this one are RF and R series RSH is a shunt resistance. Now formulas. So formulas related to this one. Now here, so first one, I series equals to ISH minus IL. So IL minus ISH, this one. So if you apply KCL at this node, IL equals to I series plus ISH. I series equals to IL minus ISH. But here I series equals to IA because these two, this field winding, ZZ field winding and AA field armature winding are connected in series. So IA equals to I series. Now if you apply KVL here, ISH equals to same voltage developed across the each elements. So this equals to ISH equals to V by RSH. This V by RSH, this voltage all are same. So this current equals to this voltage divided by this one. Now this IL, so don't use this one, it will not required. So now here EB equals to this, if you apply KCL at this KVL in this loop, so EB is algebraic sum of total voltages in a loop equals to 0. So V minus IA RA minus I series R series plus minus EB equals to 0. Now if you simplify this one, EB equals to V minus IA RA I series R series. Now these are the formulas. Now EB, here this I series and IA are same, this one, and here you can take common as a IA and EB equals to V minus IA into RA plus R series. This is the back EMF. We know this IA, EB and IA, then we can calculate the mechanical power developed by the armature. Mechanical power developed by the armature equals to EB into IA. So now next, short shunt DC generator. So DC shunt short shunt DC motor. Now here short shunt DC motor means, so first here, so one field winding is connected in series and other field winding is connected in parallel. So depending on, in the case of long shunt, this wire is connected across this one. Now in this case IL and this supply. So this series field winding and this supply is connected in series. So IL and I series are same. Now here this IL equals to I series. Now here the terms related to this short shunt. So back EMF, terminal voltage, line current, and armature current. This is the armature current, RA. Armature resistance, this is armature resistance, and I series, R series resistance, and shunt current, shunt resistance, and shunt current, ISH, and shunt resistance, RSH. So now these are the terms. So now here the formulas related to IL equals to IL minus ISH, this one. So this one, so IL minus ISH, this one. IL means that is IL equals to I series, this one. We know this one, IL equals to, this is IL means I series, we can call it. So now here IL means I series. So now here, so ISH, this ISH equals to V minus I series R series, this voltage, this total voltage minus this voltage means I series R series divided by R series, ISH formula. Next IL, it is not required. So now EB equals to V minus IARA, I series, R series. Here I series and IA are not same. So the final equation is EB equals to V minus IARA is equal minus I series, R series. Now mechanical power developed by the armature equals to PM equals to IA into EB. So now these are the four important DC motors. So this long shunt, short shunt and long shunt motor we can use as a differential and cumulative type. So if these field windings are field winding, these two field windings fluxes are adding means that is cumulative type. If they are cancelled to each other, that means differential type. Uh, sh- uh, Shunt motors we can use as a cumulative type and differential type, these long shunt and short shunt. So now here what are the applications? So now what are the first shunt motors? So shunt motors, series motors and cumulative and differential type. So only these three are most important. So first, why we are using shunt motors in the lathe machines, centrifugal pumps and reciprocating pumps and blowers and fans, drilling machines and milling machines and machine tools. Why we are using shunt machines? Because of the fairly constant speed and medium starting torque. Shunt motor starting torque is medium. So this point is most important. And so there it is having constant speed. So almost constant speed, fairly constant. So shunt motors, as shunt motors having a fairly constant speed and medium starting torque. It is having medium. But in case of series motor, high starting torque and variable speed. There is no constant speed. So variable speed of series motor. So these are used in the lathe machines, centrifugal pumps, reciprocating pumps and blowers, fans, drilling machines, milling machines, machine tools, printing machines. Now series motors are used in the conveyors and hoist, elevators, cranes, electric locomotives. So because of high starting torque, so DC shunt motor having medium starting torque and DC series motor having high starting torque and variable speed. Here these shunt motors having constant speeds. So now cumulative type. So now these are also having high starting torque. So they are used in the shares, heavy planers, rolling mills and elevators. So now differential compound generators. So speed increases, load increases. So they are not suitable for any practical applications. So now let us take one problem. A 250 volts DC shunt motor takes a line current 20 amps. The resistance of shunt field winding is 200 ohms and the resistance of armature resistance is 0.3 ohms, and find the armature current and back EMF. So first let us take the data first. Here IL equals to 20 amps and ISH equals to 200 ohms and RA equals, this is RA equals to 0.3 ohms. So now here calculate the IA and back EMF EB and V equals to 250 volts. So now let us take the diagram, given data diagram. So this is RA and RSH are given and supply voltage V is given. So now here IL equals, this is IL minus ISH. So now what about EB equals to V minus IARA. So now here ISH equals to V by RSH. So ISH equals to V by RSH. So this is 250 by 200. So this is 250 by 200. This is V and this is the RSH. So 250 by 200, that equals 1.25 amperes. So now here IL equals to 20. This is IL minus ISH. 20 minus this is IL is the 20 and ISH is the 1.25, that equals to 18.75 amperes. Now calculate the back EMF EB equals to 250 V minus IA and RA. IA equals to 18.75 and this RA equals to 0.3. Now if you calculate it, and that value is 244.3 volts. So now this only one problem here. So on DC shunt motor. So now if you have any doubts in this problem and classification of DC motors, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.